What is the primary use case of sklearn's label propagation algorithm in semi-supervised learning? A. Classifying data points with minimal labeled data. B. Clustering data into groups based on similarity. C. Extracting features from unlabeled data. D. All of the above. True. Font style quote font size 12 quote label propagation font. Label propagation is designed to classify unlabeled data by using a small set of labeled data points. This aligns directly with classifying data with minimal labeled data. Semi-supervised learning. Label propagation. Data graph. Kernel KNN, RBF, etc. Image classification. Text classification. Imagine you have a dataset of 100 images, but only 10 are labeled as cat or dog. Using label propagation, you can leverage the labeled images to infer labels for the remaining 90 unlabeled images, based on their visual similarity to the labeled ones. False. Font style quote font size 12 quote semi-supervised learning font. While label propagation considers similarity between data points to propagate labels, its primary goal is not clustering. Clustering algorithms like k-means or DBSCAN group data based on similarity, but label propagation focuses on classification with limited labeled data. Semi-supervised learning. Clustering. Data graph. Kernel KNN, RBF, etc. Customer segmentation. In customer segmentation, you might use a clustering algorithm to group customers into segments based on their purchase history, demographics, etc. However, label propagation is not directly used for this purpose. It's better suited for situations where you have a few labeled customer types and want to classify the rest based on their similarities. False. Font style quote font size 12 quote unlabeled data font. Label propagation doesn't extract new features from unlabeled data. It assumes features are already present and uses the labeled data to assign labels to unlabeled data based on feature similarity. Unlabeled data. Feature extraction. Data graph. Kernel KNN, RBF, etc. Anomaly detection. In anomaly detection, you might use label propagation to identify unusual data points that don't fit into the typical patterns defined by the labeled data. However, it doesn't create new features to support this. It relies on existing features to determine which data points are outliers. False. Font style quote font size 12 quote label spreading font. While label propagation is a technique used in semi-supervised learning, it doesn't directly address all three aspects mentioned in the choices. Its core focus is classification with limited labeled data. Semi-supervised learning. Label spreading. Data graph. Kernel KNN, RBF, etc. Image classification. Text classification. Customer segmentation. Anomaly detection. Let's say you have a dataset of financial transactions, and you've labeled a few as fraudulent or legitimate. Label propagation can help classify the remaining transactions as fraudulent or legitimate based on their similarities to the labeled transactions. However, it's not directly suited for clustering or feature extraction in this context. A. Classifying data points with minimal labeled data. Label propagation is a powerful technique when you have limited labeled data and need to make predictions on a large unlabeled data set. It leverages the relationship between data points to effectively transfer information from labeled to unlabeled data. Which of the following statements accurately describes the label spreading algorithm's core functionality in semi-supervised learning? It employs a graph-based approach, where labeled and unlabeled data points are connected, and labels propagate through the graph based on their similarity. It utilizes a clustering technique to identify natural groupings in the data, assigning labels based on cluster membership. It leverages a deep learning model to learn complex feature representations and then predicts labels for unlabeled data. All of the above. It employs a graph-based approach, where labeled and unlabeled data points are connected, and labels propagate through the graph based on their similarity. Label spreading constructs a graph where nodes represent data points and edges represent their similarity. Labeled data points act as "seeds" that influence the labels of their connected neighbors. Correct. It utilizes a clustering technique to identify natural groupings in the data, assigning labels based on cluster membership. Label spreading focuses on label propagation based on similarity, not clustering-based label assignment. Clustering methods aim to group similar data points together, while label spreading uses the similarity graph to spread labels. Incorrect. It leverages a deep learning model to learn complex feature representations and then predicts labels for unlabeled data. Label spreading is a graph-based algorithm, not a deep learning method. Deep learning models extract complex features, but label spreading operates on the similarity between data points in a graph. Incorrect. All of the above. Since options B and C are incorrect, option D is also incorrect. Incorrect. It employs a graph-based approach, where labeled and unlabeled data points are connected, and labels propagate through the graph based on their similarity. Semi-supervised learning. Semi-supervised learning is a machine learning paradigm where the model learns from both labeled and unlabeled data. It's particularly useful when obtaining labeled data is expensive or time-consuming. Label spreading is an example of a semi-supervised learning algorithm. Classifying images with limited labeled examples. Performing sentiment analysis on a large corpus of unlabeled text data. Topic: modeling of social media posts with limited expert annotations. Imagine you have a dataset of customer reviews where only a small portion is labeled with sentiment positive or negative. You want to classify the remaining reviews using both labeled and unlabeled data. Semi-supervised learning techniques like label spreading can help you achieve this by leveraging the information in unlabeled reviews to improve the overall classification accuracy. Label propagation. Label propagation refers to the process of transferring labels from labeled data to unlabeled data. It's a key concept in semi-supervised learning. Label spreading uses this concept by propagating labels through a similarity graph. Assigning tags to web pages based on a few manually tagged pages. Clustering documents based on their content similarity and a small set of labeled documents. Predicting customer churn based on historical data with limited labeled churn records. Consider a set of documents where some documents are tagged with topics like sports, technology, or politics. You want to automatically tag the remaining documents. Using label propagation, you can spread the known topic labels based on the similarity between documents. Example: using word overlap to classify the unlabeled documents. Graph-based methods. Graph-based methods represent data as nodes in a graph, where edges connect nodes based on their similarity. Label spreading is a graph-based algorithm that leverages this representation for semi-supervised learning. Recommendation systems building a graph where users are nodes, and edges represent connections based on common interests, purchase history, or ratings. Network analysis identifying influential nodes and communities within a social network by constructing a graph representing relationships between users. Image segmentation representing pixels in an image as nodes and connecting similar pixels based on color, texture, or other features. Imagine representing users on a social media platform as nodes in a graph, where an edge exists between two users if they are friends or follow each other. You can analyze the graph to identify clusters of users with similar interests or behaviors, aiding in targeted marketing campaigns. Similarity measures. Similarity measures are used to quantify how similar two data points are. In label spreading, similarity measures are used to define the edges of the graph, connecting data points that are close to each other. Finding similar products in an e-commerce catalog based on product attributes. Matching search queries to relevant documents or web pages using text similarity. Comparing images or videos based on features like color, texture, or content. You can use cosine similarity to determine the similarity between two documents by comparing their word vectors. A high cosine similarity value indicates a higher degree of similarity. From sklearn. Semi-supervised import label spreading. Model label spreading kernel rv, gamma 0.1, alpha 0.5. Model.fit x, y. Predicted labels model.predict unlabeled. This code snippet demonstrates how to use label spreading in scikit-learn for semi-supervised learning. It imports the label spreading class, initializes a model with parameters like the kernel function rbf in this case, gamma controls the width of the kernel, and alpha controls the influence of labeled data. The fit method trains the model on the labeled data x, y, and the predict method predicts labels for unlabeled data unlabeled. Correct. Which of the following statements are true about the sklearn. Semi-supervised self-training classifier in scikit-learn? A. It is a wrapper class that uses a base classifier to train on unlabeled data. B. It iteratively predicts labels for unlabeled data using the base classifier and then retrains the classifier on the newly labeled data. C. It can be used to improve the performance of a base classifier when labeled data is scarce. D. All of the above. Correct. The self-training classifier is indeed a wrapper class. It takes a base classifier as input and uses it to make predictions on unlabeled data. This is a fundamental aspect of how it functions. A. It is a wrapper class that uses a base classifier to train on unlabeled data. Correct. This accurately describes the core algorithm of the self-training classifier. It uses its current knowledge, the base classifier, to label unlabeled data, then uses the newly labeled data to update its knowledge, repeating this process. B. It iteratively predicts labels for unlabeled data using the base classifier and then retrains the classifier on the newly labeled data. Correct. This is a key benefit of semi-supervised learning. By utilizing unlabeled data along with the limited labeled data, the self-training classifier can often improve the performance of the base classifier. C. It can be used to improve the performance of a base classifier when labeled data is scarce. Correct. Given that statements A, B, and C are all correct, Statement D is also correct. D. All of the above. D. All of the above. A semi-supervised learning technique that uses a small amount of labeled data and a large amount of unlabeled data to train a model. It leverages the knowledge gained from the labeled data to predict labels for the unlabeled data, iteratively refining the model. Training a model to categorize text documents into different topics, like news, sports, or business, when there's limited labeled data. The model can be initially trained on a small set of labeled documents, then use the learned patterns to classify unlabeled documents. Building a model to identify different objects in images, where a large number of unlabeled images are available. The model is first trained on a small set of labeled images and then uses this knowledge to identify objects in the unlabeled images. Identifying unusual patterns or deviations in sensor data, where only a few examples of anomalous behavior are available. The model can be initially trained on normal data, then use the unlabeled sensor data to learn what constitutes normal behavior, allowing it to detect anomalies. Self-training. The underlying supervised learning model used in the self-training classifier. This can be any standard classifier from scikit-learn, like logistic regression, support vector machines, decision trees, etc. Utilizing logistic regression as the base classifier for classifying text into categories based on their content. Employing SVMs to perform image recognition tasks, leveraging their ability to handle high-dimensional data. Selecting different base classifiers like decision trees, random forests, or naive Bayes depending on the specific requirements of the problem. Base classifier. Imagine you're building a spam filter. You have a small set of emails labeled as spam and not spam. Using the self-training classifier with logistic regression as the base classifier, you can leverage a large collection of unlabeled emails to improve the filter's accuracy. Free money now. Click here. Spam. Meeting scheduled for tomorrow. Not spam. Your account has been compromised. Spam. Congratulations. You've won a prize. Please review your recent order details. Check out this new product. Urgent act now. The self-training classifier first trains the base classifier logistic regression using the labeled emails. It then uses the trained classifier to predict labels for the unlabeled emails. Based on the predicted labels, the self-training classifier updates the base classifier, incorporating the newly labeled data into its training. This cycle of prediction and retraining continues until a stopping criterion is met, example a certain level of accuracy achieved or a maximum number of iterations reached. The final base classifier will be more accurate at detecting spam, thanks to the information gained from the unlabeled emails.